Have you ever stopped to think about how a video of a cat playing the piano can travel from a server in Tokyo to your phone in New York in just a matter of seconds? And yet, when you try to load a website on your computer, it can sometimes take what feels like an eternity to load, even though the server is just a few miles away. This discrepancy might seem puzzling at first, but it's a great example of the complexities and marvels of the global network that makes it all possible. And understanding how it works is crucial in today's digital age, where we rely on instant access to information and communication. The reason this matters to you, the viewer, is that the ability to access and share information quickly and efficiently is a fundamental aspect of modern life. And as you navigate the internet, send emails, and stream videos, you are constantly relying on this network to function seamlessly. Whether you're a student researching for a paper, a business owner communicating with clients, or simply a social media enthusiast, the speed and reliability of your internet connection can greatly impact your productivity and overall online experience. So let's dive into the fascinating world of data transmission and explore how your data travels across the globe in seconds. At its core, the process involves a complex interplay of technologies and infrastructure, starting with the initial request you make when you type a URL into your browser or click on a link. This request is sent to a nearby router, which is essentially a traffic cop that directs your data to its next destination. The router looks at the address of the server you're trying to reach and says, I know where that is. Let me send you to the next closest router that can get you there faster. This process is called routing, and it's repeated at each subsequent router, with your data being passed from one to the next like a baton in a relay race, until it finally reaches its destination. But here's the amazing part. Each of these routers is making decisions in real time, based on the current state of the network, to ensure that your data takes the fastest possible path. It's like a dynamic, high-speed game of chess, where the routers are constantly adjusting their strategy to minimize delays and maximize throughput. And it's not just the routers that are doing the heavy lifting. The actual physical infrastructure of the internet, including undersea cables, fiber optic lines, and cell towers, plays a critical role in facilitating the rapid transmission of data. For example, when you're watching a video on YouTube, the data is likely being transmitted from a server in a data center through a fiber optic cable to a nearby internet exchange point, and then to your internet service provider, before finally arriving at your device. One of the key concepts that makes all of this possible is something called packet switching. Essentially, when you send data over the internet, it's broken up into tiny packets, each with its own header that contains information about the packet's destination and contents. These packets are then transmitted independently, taking different routes to reach their destination, where they're reassembled into the original data. This approach allows for much greater efficiency and flexibility, as packets can be rerouted if one path becomes congested, and it also enables multiple devices to share the same communication channel. To illustrate this concept, imagine a postal system where each letter is given a unique address and sent separately, rather than in a large bundle. This allows the postal service to optimize the delivery route for each individual letter, resulting in faster and more reliable service. Now, you might be wondering about the trade-offs involved in this process. One of the main challenges is ensuring that the data is transmitted accurately and reliably, with errors or corruption. To address this, various error checking and correction mechanisms are built into the transmission process, such as checksums and redundancy. Another trade-off is between speed and latency. While it's possible to prioritize speed, this can sometimes come at the cost of increased latency or delay, which can be frustrating for applications that require real-time interaction, like video conferencing or online gaming. There are also some common misconceptions about how the internet works, one of which is that data travels through the air, like radio waves. While it's true that some data is transmitted wirelessly, the vast majority of internet traffic is carried over physical cables, like fiber optic lines. Another misconception is that the internet is a single monolithic entity. In reality, it's a complex network of interconnected networks, each with its own infrastructure and protocols. In everyday tech, this process of data transmission shows up in many different ways. For example, when you're using a cloud-based service like Google Drive or Dropbox, your data is being transmitted to and from remote servers, often in real time. Similarly, when you're streaming music or video, the data is being transmitted from a server to your device, where it's decoded and played back. Recent advancements in technologies like 5G and edge computing are also changing the way data is transmitted and processed, enabling new applications like augmented reality and autonomous vehicles. In recent years, we've seen the development of new technologies that are designed to further optimize data transmission, such as content delivery networks, or CDNs, which cache frequently accessed data at multiple locations around the world, reducing the distance it needs to travel and improving performance. We've also seen the rise of new protocols, like QUIC, which is designed to reduce latency and improve the overall efficiency of data transmission. In conclusion, the process of data transmission is a complex and fascinating one, involving a dynamic interplay of technologies and infrastructure. By understanding how it works, you can gain a deeper appreciation for the incredible feat of engineering that is the global network, and how it enables us to access and share information with unprecedented speed and efficiency.
The key takeaway is that the internet is not just a magical, invisible force. It's a real, physical system with its own strengths and limitations. And by understanding how it works, we can better harness its power to improve our lives and connect with others around the world. Thanks for watching, and we'll see you in the next video, where we'll explore more of the fascinating technology that shapes our world.